two invited papers. The first of these papers is an award winner at the NSA's Best Scientific Cybersecurity Paper competition from last year. So the title of the paper is "You Get Where You're Looking for: The Impact of Information Sources on Code Security," and the presenter is Dr. Michelle Mazurek from the University of Maryland.
Do something to get my slides? Okay, thanks. So as mentioned, I'm Michelle Mazurek. I'm an assistant professor in computer science at the University of Maryland. This is some work that I did with my collaborators from UMD and also from several universities in Germany. So this was published in 2016, and I'll tell you a little bit about why Stack Overflow may or may not be contributing to the security of the software that you see. So has this ever happened to you? This is maybe a little small to see, but you're working along trying to develop some software. Perhaps you're writing some Java software using Eclipse, something like that, and you encounter a weird exception that you don't quite know what to do with. So you start typing things from this exception into Google, and you find yourself on a page of Stack Overflow telling you, oh yes, I also had this error. You know, my site was working great over SSL, but then when I used a mobile browser, I get this, weird SSL exception. I don't know what to do about it. And, I realize that's too small to read, but if you could see it, it would tell you sort of at the bottom that the correct answer for this is to sort of disable one of the certificate checks, which will magically make your SSL exception go away, which is great. So the answer suggests, just trust all certificates and all of your problems will be gone. Hooray. So it turns out that my co-authors did a study back in 2012 where they scraped a bunch of apps from the Android store and they analyzed them. And they found that, in fact, many real apps were doing exactly this. They were just trusting all certificates or just skipping the certificate check entirely. And they emailed a few of the app developers where they found these things and said, what happened? Why did you decide to do this? And a couple of them actually said, oh, well, I just pasted that code from the internet. So we thought, well, this is an interesting phenomenon. We should investigate this a little bit more. So everyone knows, maybe, that copying and pasting from the internet is, potentially bad for security. And we wondered if this might be especially true for quote-unquote amateur app developers or people who, have maybe not had a lot of experience or who are sort of building apps for themselves rather than working in a large organization or something like that. So we wanted to try and measure empirically what this actually means. And we wanted to understand, how something like Stack Overflow compares to official documentation in terms of these security properties, and whether or not, real developers out there in the world are really using this kind of Stack Overflow code, right? So we all know that the students we teach in our classes are doing this, but are sort of real developers out in the real world doing this too. Let's find out. So we started out with an online survey of Android app developers. We sort of took their email addresses down from Google Play. We sent about 50,000 of these invitations. Somewhat unsurprisingly, when you're sort of cold emailing people who develop apps, we got 295 valid responses. And we asked them questions about what strategy they use when they're looking for help with Android security or Android permissions. We asked them about, in general, what resources they use when they're programming, not just for solving security problems, but other kinds of problems. And we found that, in point of fact, the overwhelming winners were search engines and Stack Overflow. The one sort of exception to this issue is when it came to Android permissions specifically, the official documents were a little bit more popular, perhaps because this was such an Android-specific problem. But in general, Stack Overflow and search engines were the big winners in where people actually go to try and solve problems they're having when they're programming. So now that we sort of believe that this is actually a real thing, a real phenomenon, we set out to try to understand in a lab study what effect this would have on security. So we brought people into the lab and we asked them to complete 4 short programming tasks that were designed to have both secure and insecure functional solutions. 2 ways that you could make the code work, one that was secure and one that was insecure, at least 2 ways. And we assigned them each to one of 4 conditions where they were required to only use the official Android documentation, only use Stack Overflow, only use a couple of books on Android programming that we gave them, or they had a free choice to use anything that, that they wanted to use from the internet while they were working. And then at the end of the study, we conducted an exit interview to understand their perspectives on what had just happened. It's important to note here that we specifically designed this study not to prime people for security or privacy. We didn't tell them, please try to solve these problems in the most secure way possible. We wanted to understand if we just told people, you need to make your code work, would they sort of inadvertently end up with secure or insecure solutions? So that was part of the design of the study. So we gave people a skeleton app inside an Android emulator because we can only keep them in the lab for like an hour and a half, so we can't really ask them to develop whole apps from scratch. And we gave them these following 4 tasks in counterbalanced orders. A secure networking task about converting an HTTP connection to an HTTPS connection in the presence of a certificate error. So what happens if your certificate is broken? An intercomponent communication task to limit access to a service only to apps from one particular same developer to have access to this service, which you can do. You can solve this problem in a few different ways, but you could publicly export the service to any app, or you could define a special signature permission that only apps which are signed by the developer can have access to this service. We had a secure storage task where, again, we didn't emphasize this was about security, but we did say, store a user ID and a password locally. And you can put this, privately in something like a shared preference that belongs just to the Android app, or you could put it in a more public part of the storage, like, for example, on the SD card. And then we had a least permissions task involving dialing a customer support phone number. And in Android, you can sort of queue up the phone number to be dialed, but not actually call it, which doesn't require any permissions, or you can actually have the app place the call, which does require an extra permission to place a call from an app. So we had people come into the lab and complete these tasks, and then we went back and evaluated the code that they wrote. We evaluated for correctness in the sense of, does it compile and work? Does it actually accomplish the functional goal of the task? Then we evaluated it for security. Among the code that actually worked, was the solution secure according to our sort of predefined definitions of what was or was not a secure approach, and these were manually coded in these different categories. And then finally, a bunch of self-reported sentiment questions about whether or not they were thinking about security when they worked on the task, whether or not they found the resource that they used to be helpful, to be correct, whether or not they thought that their solution was secure, these kinds of things. So we recruited for this study in and around 3 universities in the US and in Germany, using email, flyers, Craigslist, and developer forums. And we required people to have either taken at least one course that primarily talked about developing for Android or mobile, or at least 1 year of professionally developing for an Android application. And we also had like a quiz of 5 really basic Android programming knowledge questions that we asked people to get at least 3 of those right in order to be able to participate in the study. So in total, we ended up with 54 people, which adds up to either 13 or 14 in each of our 4 conditions. 12 of them were in the US, 42 of them were in Germany. The majority of them, as we'll see, were students, so the median age was about 25. Perhaps unsurprisingly, the vast majority of them were also men. And of those, we characterized 14 of them as professional, meaning that in the prior 5 years, they had employment for pay developing software, as compared to 40 who were non-professional. So the non-professional were mostly students. Some of the professionals were also students, but we characterized them as professional if they had also been working in the field. So an interesting thing to note is to sort of compare the difference between our lab participants and our online participants. And we found that in general, they were actually more similar than we had been expecting, but that most of these things, the lab participants all had more formal education in programming, which is a little bit unsurprising since we recruited them from around universities, but overall they had sort of similar levels of experience. All right, so we had people complete these tasks with their different resources. So one question that we asked them was whether or not this resource was easy to use. And we found that people who had their choice of anything they wanted enjoyed it the most. People like to have choices. But that after that, sort of the official and Stack Overflow were sort of similar to each other, right? So the greener colors to the left are things that were easy to use. The redder and yellower colors to the right are things that were less easy to use. People really, really did not like having to use books. People were not a fan of using books. On the other hand, we also asked them whether these resources were correct. And in this case, the free choice people were least confident that the resources they were using were correct. And similarly, Stack Overflow people were not as confident. The official people and the book people were much more confident that their resources were correct. We also asked them, as I mentioned, whether or not they were thinking about security when they completed these tasks. We measured this in two different ways. The first was whether we asked them to think aloud while they were developing. So we took a note of whether or not they mentioned something security related at any point while they're completing the tasks. The second way was that we asked them at the end, were you thinking about security when you completed this task? So via Think Aloud, 16% said something out loud indicating that they had thought about it. And of those, 5% said that they ignored it because it was a study or because they had limited time. So they said, oh, if I was doing this for real, I would have thought about security, but I'm not because it's a study. On the other hand, when we asked them, oh, were you thinking about security when you completed this task? 60% of them said, yep, definitely, totally thinking about security the whole time. The right answer is probably somewhere in the middle, right? And this turned out to not vary particularly among conditions. So regardless of the resources they were using, this was true. So we'll get to the part that you all actually want to know, right, which is how did these people do on the tasks? So this is a graph about how many people got the thing functionally correct. And so we can see that some of the tasks were a lot easier to get functionally correct than others. The secure networking task was the one that people really struggled with a lot, along with the intercomponent communications. So we can see that Stack Overflow, which is the orange bar, and the book performed particularly well. And we have in the paper statistical analysis also showing that this is true, which I just won't get into the details of here. On the other hand, the official documentation performed significantly worse than Stack Overflow in terms of just being able to get to a functionally correct solution. So then the question is, what about security? Well, turns out the results for security were pretty much exactly the opposite. Stack Overflow, which was the best for functionality, was the worst for security, and in fact was significantly worse than people who were able to complete the tasks using the official documentation. Recall that these are only out of the people who were able to be functionally correct in the first place. On the other hand, the book again performed pretty well, and people using the book had secure results as well. We took a quick look into whether the professionals versus the students made a difference in terms of whether or not they were able to be correct or secure. The sample size for this was quite small, so I wouldn't overread the value of this comparison, but at least in our little experiment, the professionals were more likely to get a functionally correct answer, but no more likely to actually end up with a secure answer than the students were at the end. This is a topic that we explored a little bit more in a follow-up paper we had at SOUPS last year, which found sort of high-level similar results that certain kinds of security properties don't differ too much between students and professionals. So how did people actually go about accomplishing these tasks? Well, people who used the official documents did a lot of scrolling. They did a lot of scrolling up and down in the official documents looking for the particular thing that might help them find what they're doing, clicking a lot of internal links in terms of like tables of contents and going back and forth to things. On the other hand, people who use Stack Overflow did a lot of searching. So they would search with some set of search terms, look through the results they got, say, nope, that's not what I wanted, try a different set of search terms and try again repeatedly. Among the free choice people, 100% of the people used the official documents at least once during the course of solving the tasks, and all but one of them used Stack Overflow at least once as well. Exactly one of our free choice participants actually referenced the book voluntarily, and overall the results of the free choice people were closest to Stack Overflow, so they were sort of mirrored. The free choice people's results looked more like what the Stack Overflow people did. So we took a closer look at the Stack Overflow pages that were visited by our participants. So the computer that we gave them to perform these tasks on, we had instrumented the browser in order to collect all of the pages that they visited while they were working with us. And we found that between the free choice and the Stack Overflow participants, they visited 149 unique Stack Overflow pages. Of these, we categorized 41 as actually relevant to the problems they were trying to solve, which goes a little bit toward that search resetting, right? They kept finding things that weren't working and trying again. Of these, 20 contained code snippets, of which 7 of the code snippets were only secure solutions, 10 had only insecure solutions, and 3 contained both. Among the insecure code snippets that we found, 3 of them did include warnings somewhere, either either with the code snippet itself or further down in like the comments that said, hey, this solution will make your exception go away, but it also has a security problem. So 3 of those had warnings that way. So this perhaps explains a little bit of why we got the results that we got in terms of people finding these code snippets to copy from that were not necessarily secure. So now what? Well, one thing we learned from this study is that if you want functional and secure code, you should cut off all the internet in your office and require all your developers to use books. Okay, that's a joke for people who are reading the slides online later. It was true that the books actually did seem to have the best trade-off of sort of functionality and security, but we know that that's not probably a very practical solution going forward. So instead, what should we do? Well, we find that Stack Overflow helps developers find these quick and functional solutions that they can't otherwise get in the official documents, but the results are less secure. So what can we do? We need some resources that can integrate both of these features. So some things that we have been thinking about or talking about are ideas like, could you add some kind of a security rating to Stack Overflow posts to try to influence the upvote and see what kinds of posts end up near the top? Could you integrate some kind of Q&A functionality into the official documentation where you would have more authoritative people trying to answer these kinds of questions? One thing that we think is pretty intriguing as a way forward is using Stack Overflow as a source of identifying what areas lead to confusion, right? So topics that are frequently asked about on Stack Overflow seem to be ones that have problems, and using this as a guide to adding particular trouble points into the official documentation. Some other things that we noticed were that, where there's not a code snippet in the official documentation, people really want those code snippets, right? So they'll go looking for them. So making sure that the official documentation contains enough code snippets and thinking about how to organize it around errors that people see. So the official documentation is sort of more like, here's what you should do, but people go looking for information when they run into a problem. So trying to organize this a little bit around, here's a problem you might have and what you should do about it. These kinds of ideas. And I will just quickly acknowledge all the people who helped us with this work, including a bunch of students who helped with administering the study, some folks at our amazing UMD IRB who helped make this international collaboration happen. It's not too often that people get to talk about how awesome their IRBs are, so I feel very lucky about that. And then funding from several organizations in Germany, as well as the National Institute for Standards and Technology here in the US. And I'll just put these back up. And that's all. Thanks.